Hello and welcome, developers. My name is Shay, and this is another episode of Shay Develops. Today we're going to be talking about wrapper classes in Java. Now, what is a wrapper class? Well, we talked about primitive data types already in some previous videos. Integers, floats, booleans, not strings. Strings are an object, but there's primitive data types. I believe there's 8 of them, and those primitive data types have an object that goes along with them, but we don't always need it. Like if you're doing some kind of loop or something like that, you don't need to set an object whenever you just need to count a number. So let's start off with just the integer. So in previous videos, like I said, we just do int I equals 1, right? And that's the primitive version of the data type. But if we want to make an object version of the data type, and this allows us to gives us some pre-built methods and stuff that we can use on it, and I'll show you those guys in a minute. But we use the integer I2 equals, and now we can use the new keyword and integer, and then we'll just set it to 12. And you can see that my IntelliJ is marking this out, the word integer. Now this works, it totally works. I can output this to whenever I run it. I can output it to the command line, and boom. See right here, we get the number 12, which is what I set my value to. So this works, but you don't need to go through all of this, write all this code whenever doing it. There's a shorthand method in which you can just do, and this is actually called auto boxing, and then you can do this with all these wrapper classes. And then we'll be talking about something else called unboxing. But instead of doing integer I2 equals new integer, we can just go I3 equals 15, and that's it. And what that's doing is taking your primitive data type of 15 and converting it into a wrapper class. So it's now an object, and instead you can actually just do I, and you've now actually really converted your primitive data type of integer into a wrapper class. So now let's get rid of this. Like I said, we could run different kind of methods on it. So we have I3 dot using dot notation with IntelliJ. It's smart enough to bring about. We can do different things here. So if we want to check to see if it equals another object, so we could do I3 I2. And then print that out. To see if these two are equal. Now obviously we should get false. Yep, we get false, of course. Alright, so like I said, all of our primitive data types, so they have a wrapper class that goes with them. So that's integer. And by the way, if you, like I said, we talked about auto boxing. We can also do unboxing. So that is pulling the integer value out of the integer object. So we could just do int I4 equals I3, and then now just output I4. And you can also see that we no longer have our dot notation for our built-in methods, right? So yeah, they're no longer there like we did at I3. So we have toString equals in value byte type, this kind of stuff. So that's how you can tell it converted from an object back to a primitive data type. So let's go ahead and run this. And so we can get false and then 1. Because we set I3 equal to I, which is 1, and then I3 equal to I4, which is our primitive data type. So it grabbed the primitive part of the data, which is just the number, the value, and stored it in our integer variable. Alright, so let's go ahead and comment this out and move on to the next one. Like I said, and the concept of auto boxing and unboxing, it goes for all of them. So we're no longer going to use the new command. We're just going to always auto box. And then so let's say we can create a byte. We can create a short. And create a long. Oh, forgot to make that a long. There we go. Use the, if you haven't watched the primitive data types, we use an L. It can, I believe it can be capitalized too. Yeah, you can use an L at the end of your value to specify that this is a long data type. You can also use parentheses and then the keyword long before it, and that will also specify that this is a long. So if you wanted to make that a little bit more readable, I guess you can do it that way as well. And then for char, we can use character. And of course we could also do a Unicode here. I don't know what that just made, but the Unicode. We can do float. See, it doesn't like that either, so we got to make sure we put the F there for float. And double. And as I said, if it didn't like here, you can just put a D here as well. And our last one is Boolean, which is just a true false value, right? Oh, it doesn't like this. Oh, B1 is already defined, so there we go. So now those are all our wrapper classes. Like I said, there's things that we can do with our wrapper classes, like bool1 dot. You can output the Boolean value, and there. Go ahead and run that. And see, we outputting true, which is what we defined it to right here, Boolean true. Now you might be thinking, well, why would I want to use an object over a primitive data or primitive data type over these objects? What's the value from it, right? Well, with primitive data types, they're erased and removed using the Java virtual machine after a thread has completed. Now this may be a little over your head though, but after a thread is completed, it erases the primitive data types that it was using. Whereas objects are all objects are stored on the heap, and that is a place where Java has allocated memory to store your objects, so that way it can go back and get them whenever needed. And these objects are semi-permanent, as far as while the program's running, if it finds that the objects are useful, it keeps them, and then while it's going through its garbage collection state, if it finds that it's not using the object, it'll go ahead and remove it. But more than not, you're going to be using these objects, so it's going to keep them. So that brings a little bit of bloat to your code where you may not need it. So like I said, if you were to have, and I haven't went over this yet with anybody as far as on this channel, but if we had a for loop and we needed to count through 10 iterations of whatever it was that we were counting through, and we specified this integer value right here to be an integer, like so, which we can totally do. If we specify that, now that integer I is going to stay on the heap even after this for loop has already been completed and moved on, and we don't necessarily need that or want that. So that's one of the benefits of using a primitive data type over an object. But I said a lot of times, though, you may want to use an object over a primitive data type. Since Java is almost 100% object oriented and built around objects, so more than likely you're going to be want to use an object, except for in these cases where we want to use the primitive data types. Alright, so hopefully you guys understood that and it wasn't too convoluted. If you guys are wanting to learn anything else, put it in the comments. I'll see if I can't make a video on it. If you guys want to help me out, I have a book that I wrote. It's the HTML5 Learning and Reference Guide. At least if you're learning Java right now, it's probably not relevant, but it's $2.99 on Amazon, and it's super helpful. I wrote it a while back while I was studying web development, but it'll be super helpful to me if you guys purchase it. It'd be pretty awesome. But other than that, you can like, comment, and subscribe. Let me know how you feel, good, bad. I want to make these videos as helpful as possible with very little editing. I just come in here and start typing and start talking to you guys, because programmers, we make mistakes, we do things wrong. You're gonna see that from time to time. But anyway, I hope you guys have an amazing day. Y'all are awesome. Peace.